0.069. It says write an equation that models the population of Greensboro T years after 1984. So it's asking you to use the variable here. That doesn't give you a final population, so we're going to use a y. Okay, when we set this up as an equation, we should get y equals 197,910 times 1 plus 0.069 to the t power. Okay, so this is how we would create an equation. And I want to make sure I go through solving so that you guys can solve these problems on your classwork and your homework tonight. Okay, so it says to find t, you can use logarithms to rewrite the exponential equations. You also can use your calculator. It is much easier on your calculator. Make y1 your left-hand side, y2 your right-hand side, and then find the intersection. Okay, I will also show you how to do this on Desmos. Okay, so first let's identify our F, I, R, and T. So it says Alex invests $2,000 into an account, so that's our initial amount. Has 6% annual rate of growth, so my rate is 0.06. To the nearest year, when will the investment be worth this much? So this is my final amount, $3,600. We're looking for how much time it takes to get there. So we're solving for that t. We're going to set up our equation just like we set up this one. So our F value, oops, sorry, we're going to get white out. Our F value, in this case, instead of y, we're going to write our final amount. So 3,600 should be equal to 2,000, 1 plus 0.06 to the t power. Okay, so on Desmos, I think most of you are probably using Desmos. Make one equation with y equals 3,600 and another equation as y equals 2,000, 1 plus 0.06 to the t power, and then we're going to find the intersection. Okay, so I'm going to show you how to do this. It's very easy once you figure it out. So let's downsize this a little bit. Pull up Desmos. Okay, so I did one earlier today while I was making your practice. So our final amount is the 3,600. We have 2,000 as our initial amount. And then 1 plus 0.06. We get rid of this guy. And you guys can see here, the red is our exponential function curve. Our blue is our final amount. We just find the intersection, just click on it. Okay. The t value is going to be your x value. The $3,600 is right there. So we get t is about 10 years. Okay, so in about 10 years would be our solution. Okay, decay is going to work. I know we only have 1 minute left. Decay is going to work the exact same way, except we have 1 minus r for our b value. Okay, so what I'm going to do, since we only have 1 minute left, is I'm going to fill this whole thing out for decay as well. And then I will post it on Canvas so that you guys can go back and fill it in. And I will extend this assignment through Friday so that you guys have plenty of time to ask questions and get this in. Okay, so your assignment today, so I'm going to post this online, so don't worry that I'm taking it away. I'm really sorry. I'll post it immediately after class. So today, you are going to do, there's only one classwork activity today. It is graded, so do it. It will count for your Unit 1 grade. Okay, so you're going to go to this creating and solving exponential functions. There are 4 problems on growth, 4 problems on decay, and I'm just going to show you what it looks like. So you're filling in blanks. You want to identify your F, your I, your R, your T, and then you're going to fill in the equation. Okay, so you'll have your Y value here, or your final value, your initial, your rate, and your time. Some of them will ask you to also solve for parts of the problem, okay? But for all of these, you're identifying your F, your I, your R, your T, and at least filling in the equation, if not solving for something else. Okay, what questions do you guys have before we head out? Okay, I know we went so fast today, but it is 1 minute past your time for synchronous learning today. If you have questions, feel free to stay on and ask them. I'll stay on however long you need to answer your questions. If you don't, if you're confident, you're good to go, you are free to leave. And I will see you guys tomorrow.